to
electricity.
power. Turn on the power. That switch is right here.
Right.
It's on.
Ooh, that was complicated. I might need to take notes.
So I will try to make a more detailed notes in the future, hopefully. So basically this is a 3-axis CNC router, which means it's designed to cut stuff. What type of stuff? Wood, soft stuff. So we can't do steel.
Humans.
We can do aluminum. Doesn't do the best job on aluminum, but it's strong enough to cut aluminum. So what we have is your, here's your router motor. And so the thing about when you're cutting wood, it's very high speed. So in order to cut steel, you want to have the low speed. And this just doesn't do low speeds. Plus it doesn't have enough torque to do low speeds as well. And then inside here, so basically Z, X, and Y are your 3 directions. And then in here we have basically a clamp. Basically, you don't want to stick, in general, you don't want to stick what you're cutting right on the bottom if you're cutting all the way through. Otherwise, what happens? You start cutting up your table, and then we're not very happy. So what we have is these are little offsets, and they have a little lip on them. And then this can be slid inside and out. And so basically there's a lip here, a lip here. So you can basically set up your workpiece so that it's on here, and then so it's flush here, and you can clamp it down like that. So where do we want to be 0, 0? Where's our reference?
The corner?
The corner. This corner here is against a clamp on either side. It might go bigger that way, it might go bigger that way, we're not sure about that. But once we bolt these things down, then this corner is basically our 0 reference when we're designing our part. We basically have a stock of wood. So basically what we're doing, we can start off in SolidWorks. You know what SolidWorks is for. We can take our part in SolidWorks, export it in a file that Mastercam, which is the CNC software, can read. What the CNC software does is take the geometry you've generated in SolidWorks and creates a CNC code to actually cut out that geometry. Then from Mastercam, you're exporting a CNC file, and then the CNC software program is actually what does the cutting. So what do we cut with? An end mill. This is an end mill. This looks sort of like a drill, except where do drills cut?
Holes?
Drills cut holes, so they only cut on the tip. This has sharp edges on either side as well, so you can cut faces like this, you can cut off the face, things like that. So you can do more complicated parts than you can with a drill. This is the flat end mill, because it's flat on the bottom. And then we also have
It's a nice box.
It's a very nice box. We have rounded tip end mills as well. So if you have a complicated sculpted surface, then you would use a round end mill to cut your surface. Now, how do we hold it in the machine? This is what's called a collet. And so basically it's a clamp, so as this is screwed in, the collet is going to grab, and it's going to grab your your tool, and so that it can't slide once it's in there. However, because it's a collet, the vertical height, you always have, whenever you change a tool, you always have to tell it what the new vertical height at the bottom of the tool is. So we'll learn on how to do that when we actually go to machine that. So there's different collets for different size diameters. So this is the epic fail. Not the epic fail, it's just a minor fail, right? How are you supposed to machine?
I wanted epic.
With the doors closed. However, where's the emergency stop button? You have to open up the door
That is an epic.
to press the emergency stop button. It's usually not on fire. It's when your program doesn't work quite when you think it does. Whenever you're dealing with moving the machine, always wear safety glasses.
You can get Sonics all over you.
It's not the sawdust problem. It's when you move it where it doesn't do. So one thing we need to do is figure out where tell the machine where 0, 0 is on the part. You can do that by moving your end mill around until it just touches the part. When I was at Georgia Tech as a grad student, I was actually programming a CNC controller, so I was just designing the controller for the machine, not actually machining stuff. But when I was doing a demonstration, I was trying to set up something, and it was sort of like this, where you have to move the machine around using the keyboard, and then in here, and so the machine was on rapid rather than slow, and so I moved it rapidly rather than slowly, and the machine was more powerful than the end mill, and so then I had the end mill bouncing around in there with me, in my head in there. Fortunately, it didn't hit me in the eye because I wasn't wearing safety glasses. So you never know when accidents are going to happen. I wasn't cutting, so I didn't think things were going to be flying around. That's why it's called an accident. It's because we didn't intend to do things. So whenever you're moving around the machine, even if you're not cutting, please wear safety glasses. From personal experience, at least I have 2 eyes. But if projectile motion would have been slightly different, I could have had a more serious problem. All right, so our old friend is SolidWorks. We're pretty familiar with that, right? So this is still, we're using SolidWorks 2010, right?
Yeah.
SolidWorks is evil, as Andre has found out. If you draw something in SolidWorks 2011, there's no way you can read it in SolidWorks 2010. Once you open a SolidWorks 2010 document in 2011, there's no way to move it back to 2010.
Does that in like every program?
No.
AutoCAD?
AutoCAD, you can save it as a previous version.
Oh, okay.
SolidWorks, you can't. So once it goes, it's a one-way door. What you can do is export it. You can open up your SolidWorks drawing in Autodesk Inventor, and then save it as a previous version of SolidWorks from Autodesk Inventor, losing a little bit of your detail. So anyways, so we're going to generate a new part. What do we want to generate? So let's do a new part. Double click. Triple click? There we go.
Quadruple.
All right, so we have X, Y, Z just like before. We're going to jump into Mastercam to see where we want to end up with our part.
X cubed. Nice. 6 flags, right? Yeah.
6
Going on
flags?
Saturday.
It's X2.
I'm going on Saturday.
Oh.
Yeah. They have X2. This is X3. It's the next level of awesome.
Okay, so basically what you're doing, you have X, Y, and Z. So when you set up so basically you're setting up your profile in X and Y. So therefore, when you set up your drawing in SolidWorks, what's the default setting?
X, Y, Z.
Y is up. Right, when it comes up, Y is up, and Z is towards you.
You need to flip it over.
So you need to make it so that your part is in the XY plane, not the XZ plane like I did yesterday. Because then you have to rotate your part around. And it all gets confusing. So let's create a new sketch. So we basically want to sketch our plane in the XY plane, which is the front plane. And then basically it's a 2x4. What size is a 2x4?
2 by 3 and 3/4.
No! A 2x4 is not 2x4.
By 3
It's 3.5 by 1.5 by however long it is. So we can basically generate our 2x4. We want to start at 0, 0. And then generate it like this. So we want it to basically be in the same direction as we're going to put it in our clamp, so then we don't have to mess with stuff as we're going around. So there we go. And smart dimension, this direction is 3.5. This direction, I believe, was 10. So now we have a 3.5 by 10. And then what do we want to extrude this 1.5. And probably want to extrude it down. So we basically, our top surface will be the top surface of the part. And it's going to go inside, below. So basically, when we set up the tool, we measure where the top of the part is, not where the bottom of the part is. So when we set up our workspace, we also want it down into the part. Beautiful. Okay, so now we have here's our 2x4. What should we do with our 2x4?
Draw something up.
What should we draw on it?
Some fillets.
Fillets? Fillets?
Fish fillet.
A fish fillet?
You should put the In-N-Out logo.
In-N-Out logo.
Or hang that another.
Fillet.
That would be easier to do in SolidWorks, Mastercam. You can import graphics and then convert it. So if you look over there, there should be the CBU logo. That I did that way. That was a year ago, so I don't remember. Don't want to do that real time.
SolidWorks won't let you import graphics.
SolidWorks will, but how are you going to convert it? So SolidWorks so basically SolidWorks you can import a graphic, but it's just a picture, and then you have to draw the lines for the graphics, where the other program will automatically generate the bounding curves for your graphics.
I see.
So it's one step faster. All right, so fish, do we want to draw a fish?
So hard.
What does a fish look like? So draw a sketch. We want a fish, is that what we want?
What do fish look like?
Do the Christian fish.
The Christian fish?
The Christian fish. That's easy. That's like 2 arcs.
It's like 2 arcs? Oh, that's right, it is. So how is that? Like this to 1, no, center. I'm not that good. So we want to go from here to here. This is just a bad fish.
It's not a Christian fish. It's a bad fish.
It's a bad fish. From here to here to there. There we go.
Okay, the Christian fish is in there somewhere.
In somewhere. Okay, so we have our
It's facing to the right.
2
He's
circles.
kind of swimming downward.
Yeah.
So we want this and this to be equal. And you want, let's draw a construction line like that. It's for construction. And then we want, can we do the intersection or no?
How did you not do the intersection?
Oh snap.
Yeah, in AutoCAD we could.
It's just a piece of glass.
Oh, that's what fun part. It's a happy piece of
It's a very creatively designed piece of glass. I like the rectangular nature of it.
It's good.
A little bit of dusty blur coming.
That's snapping. So if we merge this and that, and this is for construction. Yay!
It made it magic.
All right, our fish is getting more fishy. So now we can trim that and that. Maybe smart dimension. That maybe 2. And
That's not even a part of it.
that. There we go.
Oh, it's a Christian fish.
Now it's a Christian fish.
Except the Christian fish
Oh my
didn't have a
God.
tail. It
Christian
had a
fish
tail. It didn't have the line.
Didn't have the line?
No, because he did the two.
The fish, the fin line.
Because
There
it
was
was
a fin line. And then, let's see, select midpoint, and that we want to be coincident.
Nice.
And
I like how we're dimensioning the fish.
I'm pretty sure that early church did that
then they had a CNC machine to.
too. Yeah.
All right, so this is a beautiful fish. The
Yeah,
problem
that's
with
all
this
those two.
beautiful fish,
Yeah, like SolidWorks too.
There's no eyes.
it has no eyes.
Like SolidWorks.
Well, how are we going to make this beautiful fish?
You have to cut it into the wood.
We have to cut it either into the wood, which we can either have our fish sticking up, or we could have our fish
Sinking
cut
down.
in. But when we're going to cut it, we're going to have to use
A tiny blade.
a circle, right, to cut our fish out. So therefore, we can't do sharp corners. Either inside or outside. My eyes are diameter of 1/8. All right, so if we use a 1/8 diameter, is the smallest flat thing we have. The problem is with a 1/8, it's going to take a while to cut out the insides because you're only using a 1/8 diameter. So there's a compromise between how accurately you can do things in terms of sharp corners and how long it's actually going to take you to do things. So, which do we want to do? Do we want to cut it inside or outside?
Or we could cut along the lines.
You just cut the lines and then draw a big hole for the eye.
So we can't cut along. Okay, so we can cut along the lines, but we still can't get this sharp corner right here.
Even when you follow the lines.
We're okay with a non-sharp.
Okay, so how do we make a non-sharp corner?
Fillet it.
We
Fillet.
fillet it.
The fish. Oh my.
The fillet of fish. I hadn't thought of that.
Sorry.
Did anyone plan for that? Like,
All right.
it's just great.
So we have to fillet our fish.
What did you do in class
You're
today?
welcome.
Can we do 1 divided by 16? All right, so if we fillet this and that, why can't we fillet these? We want to fillet.
To this line, maybe?
We want to fillet this arc to that arc. She doesn't like filleting. Can we split them?
Is it because you mated them or you conjoined them or something earlier?
Well, let's just draw a.
Oh yeah. That's the way you go.
Oh, baby, I'm
See, a
recording.
3-point arc from here to here. No, I want to go the other way. So we're going to go from this to there to. What the heck?
It's the center point. It's true.
It's possessed.
Fillet of fish is possessed.
No,
The last
the.
thing.
Let's see.
Can you
So-
relation tangent?
All right, so now we have tangent, and then we want. I want a radius. Can you give me a radius? No, you can't give me a radius.
It's probably good when you connect on this too good.
Awesome.
Control.
Just a little bit.
All right, so we're filleting our fish. Mirror it, that's a good idea. We already have a line to do that. Mirror, we want to mirror that about that.
Ooh.
Ooh. It's magic.
And then we want to trim that and that, 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 that. Too many constraints.
fish anymore.
It's not a Christian fish.
He has been circumcised.
You're not a Christian.
More than that.
Who are you to judge, Jim?
I'm a Christian, okay?
Who are you to judge?
All right, so here we have our Christian fish.
Aren't there more corners now that are smaller than right?
Okay, fine.
Well, again, if we're cutting around the outside, we only have to have the concave corners.
Oh, okay, we're cutting on the outside.
Right? Are we?
So it's sticking out?
So we will have a sticking out fish.
Okay.
You gotta fillet the top right corner if we're not doing sharp corners.
What? No, it's only the concave corners that you can't do sharp.
Okay. Could you tell the machine to cut it so that it cuts the two arcs separately and doesn't go around those corners? So like instead of cutting it like, instead of cutting it like that, you could have it cut one like that and one like that.
You could, but I'm not sure how to do it easily.
Okay, that's fair.
Yeah, I need to figure out how to have it cut an actual path rather than a shape. So the ones I was able to figure out quite easily are the shapes. So you can have a sharp corner right here, but inside here you have a rounded corner.
Is that the black heart from Valentine's Day?
No, that's the heart from yesterday, and this is a happy face from the previous year. So I can
Why
pass
does the
that.
happy face look so much smoother than the heart?
Feed rate.
Heart.
What is it?
Feed rate. So the faster you move your tool around, the more fuzzy it's going to be. So you can easily sand it off. But yeah, I was basically speeding through because I didn't want to wait. I just wanted to make sure it was working, and it's working.
Why do they? Never mind, that's a question.
That's another, okay. All right, so there we have our fish.
Yeah.
And what else do we need? We want to cut this down.
We need to extrude down.
So we could add say a rectangle like this.
Wait, so the nose and the two tips and the tail will not be rounded or something?
Cutting around the out, we're going to have a sticking up fish.
Oh, so you can stick up fish.
Ah,
Let's make this 0.25. Right, so there we have it sticking up.
Can we give it an eye?
Sure.
Can we give it a nose?
An eye for an eye.
A nose for a nose?
And a tooth for a tooth.
Yes.
We need giant fangs.
All right.
Okay.
It's a piranha.
Yeah, it's a piranha. It's a Christian piranha fish.
He doesn't kill anybody. He just.
All right. So we want to sketch on here. Yeah, sketch. And then we want to give it an eye, let's say, right here.
Unless it's one of those sandfish and they have two eyes on the same side.
Is that a good eye for a...
Yes. It's not the tuba.
And what...
What?
It's not a duma.
I'm just saying.
Look at this.
Our tool is going to be 1/8, so we'll just do 1/8. All right, and we want to... what do we want to do with that eye?
Extrude down.
I want to cut it.
Cut it. Extrude
All the way
cut.
through.
Well, the quarter inch, okay. All right, so now we have a beautiful fish with an eye.
I think he needs a sinusoidal pattern going through it, like a little wiggly line.
A wiggly line.
I think that would be a good artistic
Is
test.
that being too complicated?
Let's just go to the next
So it's
fish.
just pattern running through the fish.
All right, we're going to call this fish.
Fish fillet.
Fillet of fish.
Fish fillet.
Word. I just realized there's a no smoking sign in here.
Yeah.
Too bad I already come here to smoke every week, man. I don't even know.
All right, so now we have it in SolidWorks.
That's who said that, just in case it ever smells like smoke in
I
here.
did. Okay, fine.
So basically, if you export it as a parasolid, parasolid, like two solids, parasolids, but it's different.
Not an umbrella.
Parasol, the little woman's umbrella.
That's your geometry. All bodies. So that basically exports your geometry into SolidWorks. So now I can go into Mastercam and open from the desktop.
Fish fillet.
Where is it? Why is it not finding?
Right below AutoCAD.
Right below AutoCAD.
It's the seventh one down.
There it is. Thank you. So here's our fish fillet. And so here is our fish fillet in. Where is this at?
Mastercam?
Mastercam.
Does scrolling go the normal way using Mastercam?
In, out.
Or does it still go backwards? Because when you scroll in on SolidWorks, it goes out.
Well, not nice.
Yeah, I think it's going the normal way.
I'm pretty
So up here we basically have our zooming thingies. So we can zoom it from the top, or the front, or the right.
Oh, like the right.
Like the right. It's a very
It's
nice
entertaining.
block.
You blockhead.
But we would basically want to design because this can be used for a 3-axis, a 4-axis, a 5-axis. The Mastercam does. We only have a 3-axis CNC. So all of our paths are going to be on the top.
Oh.
See, there's some that the whole head can turn sideways and things like that. This is not one of them. All right, so what do we want to do? So basically here is, you get your geometry, so now we have our geometry which we can use to generate, so hopefully we can generate this. So the first thing we need to do,
Set your origin.
our origin is at here. What's going on? Why is it not? Where is the corner? Oh, first thing we need to do is tell it what machine we have. So what we have is a mill, and we have a techno servo mill. It's the only option there to select. So now we have a mill, and now we have over here machine group, and then properties, tool path group. So in the properties, one thing you want is your stock setup. The stock is the part you are printing. So basically, we can basically need to tell it the geometry of the part that we're doing. So we can do select corners. So one corner is right there, the other corner is right there. So our part is 10 by 3.5 by, it doesn't know how it's actually 1.5. Actually, it's been milled down, so it's not 1.5, but we'll do that. Oops. So, and then we want to display our stock, see if we got it all right. So it all worked out right. So basically now we have the red dotted line. That's where we told it where our material is, which actually matches the material we told it we had. So, first thing we want to do, typically, right, thank you. Right, we have a rough face. We don't, we want a smooth face like this, not a rough face like this. So to make a smooth face, the operation, does anybody know what the operation is?
Sanding.
What? It's called facing. Oh. to basically cut off a layer of the face, it's called facing. So, I'll leave it up here just in case. So the first so basically you come up here, your tool paths, you have choices of drilling, milling, and then, so this is with the CNC machine programming, And then we have a contour, a drill, a pocket, face, 2D high-speed engraving. Contour is the word I was looking for. So those are the basic operations. And so the first operation we're going to do is a face. We basically give it a new CNC name, so it's fish fillet. So what do we want to face?
The top.
We want to face the top surface. So we can select a chain. Let's see, is this going to work? So we've selected our top chain. Hopefully that goes all the way around. Now it asks for tool path parameters. We need to give it a tool. In our library tools, it would be nice if we had an 8-inch face mill. It's a tool that's 8 inches wide, but we don't have that. What do we have?
A little guy.
We have a little guy. We have a tiny guy, but that would take forever. And then we have a slightly bigger guy. What do I do with my slightly bigger guy? Yeah, that one. That is, I believe, a 1/2 inch. Yeah, it's a 1/2 inch flat end mill. And so we come down here and one over there. It is 1/2 flat end mill. So we select our part, and then basically the top of this. Basically, what we need is the top of the stock where the top is actually going to be. The top is going to be at 0. How far down do we want to cut this?
Quarter point something.
0.05?
For the facing?
Yeah, for the face. Let's just do 0.1.
Okay.
And then your max step over is it's basically going to have to go zip, 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 zip. It's basically what you're saying is you're going 75% over. So you don't want to cut right here and then have the next path right.
It's like lawn mowing.
Like lawn mowing. You don't. Otherwise you could end up with a gap because when you're cutting it, it's generating a force, and so that's going to cause your workpiece to deflect, and so you could end up with sticks, and so you basically want some step over. So that's your step over. You have basically climb or conventional. It actually goes both ways. Did you guys talk about climb milling and conventional milling in materials and manufacturing?
Nope.
All right, so basically what do you have? If this is your workpiece that you're cutting, this is your mill. Here's your sharp part of the tool. So basically if you're going like this, what does it want to do? It wants to pull it up. So that's called climb milling. If you're going the other way, and as you're going around, it wants to push it down. So you're pushing, this one you're trying to pull it away, the other way you're trying to push it down. So conventional milling is pushing it one way, climb milling is going the other way. It's going back and forth, so it's climbing one way and conventional the other way. But if you're going around the outside perimeter, then you can either choose climb or conventional, and it actually makes a difference. Other fancy stuff. So basically we gave it our tool, we gave it the parameters, we hit OK. So there's our tool path. And yeah, so now we can basically simulate what's going on. If we hit play, what just happened?
Nothing?
Nothing.
Incredible Hulk.
Why did it not play? Oh, our depth we said was 0.1. So when we're done cutting, we're cutting with our tool 0.1 inches positive. So if we make our depth actually negative, then when we do our simulation,
I feel like a positive depth is
it's a misnomer.
yeah.
Whoa, that could happen.
Yeah, so if it's happening, this is the running guy quickly. If you want to see what's going on, there's a walking slowly guy. And if we run it, we're going to go down, zip, 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 zip.
So that's why there's
Why is it not doing straight lines on the end there though?
Because it's a round tool.
So what, basically what we said is we want this part here, this edge right here flat. And this part over here is actually going to be in the air. So basically, geometry, let's add, can we add another chain? Let's try that again. Let's delete our facing. It's actually, it's a tool pass, face, select the chain. Let's select the bottom. Can we select the, yeah, let's select the bottom chain. So that's a rectangle all the way around. When we selected this top chain, it only had the top portion. Still want to do it a flat end mill. We still want to go, whoa, not 1.5 inches. Minus 0.1 inches. Yeah, that's not.
Personalized
Right,
toothpicks.
so now we're actually going all the way across. So now if we simulate it, it's going zip, zip, zip. Is that better? So basically what it's thinking is the rest of it is in the air, so it doesn't matter as you're lifting over it, as you're going past and turning around and over in the air, you wouldn't get those rounded circles.
Oh, okay. It doesn't know that.
It doesn't know that the other part is not there yet. So we actually want to face the whole thing so that the top of the fish isn't bumpy
So there is
either. So yeah, that's what happened there. I faced it, but I didn't have the right geometry of what I was facing. All right, so we've added that. We're on our way. What's the next thing we want to do?
Cut the fish out.
Cut the fish out, and this is a little awkward. Let's actually, can we create a rectangle? Let's actually look at it from the top. The problem is, well, let's just show what we've got to begin with. So we basically want to create, is it work with the contour? No, that's just the outside. So we basically want to do a pocket, and we want to do a pocket with the fish and with the outside rectangle. And we need to now use what tool?
Mill.
We need not a 1/2 inch mill. That's gonna we
1/8.
sized it for a 1/8 flat end mill. And then we want to go, the top of the stock is at incremental. So basically, when we change the tool, now the top of the stock will be at the top of the, after the facing. So it's actually an incremental. And the depth, let's say minus 0.25. And XY stock, roughing finish parameters, step over change, spacing. We want our feed rate, let's say, to be 20 inches per minute.
You're going to be here to help us with this when we do it, right?
Yes,
It's
but either
1/3
Wes or I
inches
will be
per
here.
second.
So this is just to give you a concept of what you can do.
Yeah, because I'm not going to remember all these settings.
I'll actually have better instructions. And so now, if we simulate what's going on, all right, let's speed up our guy a little bit. So zip, 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 zip. Now we're going in.
Yeah, that was a pretty random circle.
So basically what it does when it does a pocket is it goes around in a circle in the middle of the, not near any edge you want to keep, so that you're not, because you basically, you could, with a 2-fluted room, there's plenty of room for the chips to come out. If you have a 4-fluted room, it gets a little crowded. So if you just plunge straight down, sometimes you can end up with a bad.
Why doesn't it just start at the edge and go in?
when you have a pocket, you're saying you want all of your edge surfaces to be good. So if you start at an edge, if something goes wrong, then you're going to cut away the edge which you want to leave. So you start in the middle where if something goes wrong, it doesn't matter.
Okay.
You don't have to.
And why didn't it do the eye?
Why? Because we didn't tell it to do the eye. What we told it to do is we told it the outside surface and we told it the edge. The problem is now we have a little bit of a corner, right? If we look at it, right, we have this corner here because we don't have a square, right, this is from the round. So basically we told it we want a box like this and it can't cut out this corner.
Can it go past the edge to cut that out? Though?
It can, but we have to tell it, so basically what we have to do is create we need to create a box that's past the edge. So if we create a rectangle that goes past all of our edges, so now we have a rectangle that goes past the edges. So now if we do a pocket using the fish and this box, now our rounded corner will be beyond the edge. Still want to use our 1/8 inch end mill and feed rate, let's say 20. So now when we do it,
Positive depth.
positive depth, no, it's 0. Minus 0.25.
That'll make it really difficult to cut it.
Yeah, it goes really, you can cut really quickly through the air.
Yeah.
All right, so now if we do it, it's zipping down. Zip, zip, zip.
Is there a reason why it's doing a different pattern than last time?
It chooses however it wants to do it.
It's a boat. No, it's a fish.
So basically, you end up with rough edges, and the last thing it does is should go all the way around to smooth things out.
Do it.
Let's do it.
Wait, we gotta do the eye.
Oh.
Fish is in the eye of the beholder.
Yeah.
Yeah.
Most fish are
Right? So so basically what we can do is select our circle. Did I select our circle? No, I didn't select our circle. Escape, come on. All right, tool paths, drill. We want to drill to the center of the eye. And we'll just use our flat end mill. Top of the stock is at 0, and the depth is, say, minus 0.1. All right, so now our fish, let's see, does our fish have an eye? Select everything, and let's go.
It's fun to watch.
What? Oh, because that's certain middle, so there's a screw up.
And then we clean up everything, and now we're happy.
Did it make
Oops.
it? Positive.
I don't think we made it.
Our eye.
Is it deep enough? No, we didn't tell you. Good.
Oh, there is something. Like, oh no, we're back in.
All right. Anyways, we'll make it 0.25, and that will be the same depth as the fish. And regenerate it. Okay, so basically we viewed it. We'll trust that it's okay because it's the same depth, just because we're running out of time. Now the G1, the codes for a CNC machine are called G codes. G for go. So basically, if you're telling it to go to a position, you'd say G something and something. So basically, if you hit the G code, the G1, it generates a G code for you. Post all, yes. And so it's saving it in the, it automatically saves it in the NC file, which is where the servo programmer looks for it. So basically here is our G codes, G0, G90, it tells you to go, 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 go. What we forgot to do is 6.4. We want this to be 20 point, yeah. 6.4. All right, so that's speed 20. Let's see. Oh, 6.2, let's make this. All right. So we now have our CNC file. Did I save it? I don't know. So now we go into TechnoServo CNC interface. Emergency stop is on, so it won't run. Shut it. So here's your interface. So you can basically file. It's from the 90s, yes. That's fish fillet.
You can tell, yeah, fish using different letters.
Using different letters. So we can preview.
GH as in enough, and then
What?
There's a silent D.
TI is like shun, like vision, or tuition.
Is there a D in there?
No, it's goatee. There's like 12 ways to spell fish.
That looks better.
It's all green. It's all green.
It's Christmas time.
There's wonders like I've never seen. It's all good. It's all good.
All right. Save this. And now, so we basically, when I did preview, oh, now it's working. So basically, this is the path it's going to follow. First, with the first tool, it's going to go zip, 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 zip to face it. Then it's going to go back and forth, and then this last is the screen plunge to do the eye. So that has everything we want it to do. Pre-process basically runs it, so it's going to take 20 minutes to run. So we're not going to see the whole thing run probably, because we only have, we have 20 minutes. So if we can get it started soon, we might get to see the whole thing run. Okay, so machine's on, so I'm going to put on safety glasses. Nothing ever bad happens.
Yeah, something like
Boingo Boingo. They have a song called Nothing Bad Ever Happens to Me.
that. Oh.
Okay, first thing you need to do is figure out, well, where's the big mill? All right, here's the big mill. Big mill in the sky. So we basically need to tell it where 0, 0 is. Now this is the point where you all should be wearing safety glasses, even though it shouldn't make a difference, but
All of us?
it's all of us, yes, unless you have glasses on. Contacts.
Yeah, you're really protecting.
All right, unfortunately, these are the only ones we have in here.
All right, let's get some video
I'll wear
footage
all of
this.
them.
So,
I'm wearing one of these for glamour. Oh, yeah.
we're not here for.
So we run out of safety goggles, I'll give mine up, but they're pretty fun.
All right, sorry.
One for yourself.
Not the highest. Unfortunately, this is a. Everybody got glasses? All right. I predict nothing is going to happen. So basically, what we have is the collet looks like a nut, and then right above it is another nut. So if you go right, tighty, lefty, loosey. So here is the other tool.
Shouldn't have been that funny.
All right, so we basically have our tool. Now we need to tell our machine where the edge is. So it's set up that you can do X, zoom, go X, go Y. You can't do Z with the keyboard. So basically we want to go beyond the edge of the part, and then go down past the edge of the part.
Is there a keyboard key for Z at all?
No, I don't think there is. There might be. Now our jog speed is how quickly we're moving. Now that we're getting close and we might run into things, we want to slow down a little bit. So you basically bring it to the edge. Now we want to step, which is going, so continuous is quick, step is more slowly. So basically we want to move our tool, we want to make sure that the cutting edge is there, and then we have a very calibrated piece of paper. And right, the paper nicely slides, so then we can move up. Now the paper doesn't slide anymore. So now we can back away. Paper is free. You're jogging 1,000th at a time. Now we can lower this to 1,000th. And then jog in one step at a time. Whee. All right. All right. So paper caught right there. How big is the paper? About 3,000ths maybe? So you do 1, 2, 3. Now what we want to say, now we want to 0 our X. Because we were moving in X. Now we basically back away. Paper fell down. Now we can go back to continuous. Back away from our part. This is where I went the wrong way and broke off a tool. Fortunately, it was only a 1/4 inch end mill. Now we're basically, so we zeroed it on one edge, and then we want to zero it on another edge. Again, you want to make sure that the edge of the tool is facing the, and 2x4s are rounded slightly, so we're going to want to go down a little bit. And then let's do continuous and make this guy good. Fine. All right, we're stuck. Yep. Oh, I stuck it in the whole thing. It's jumping a step at a time is what it's doing.
Okay.
And so rather than doing a smooth motion, you're saying jump, 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 jump. Again, go back to 1,000. Wait till you can't move. Come on, catch, and then 1, 2, 3. And then we want to 0, this time we want to 0 our Y. Now we want to back away, take our paper out, and then that's go back to continuous, back away a little more, take our Z up. That's a little slow. All right, so now, where do we want to go? We want to set actual 0, 0. What we set, we moved a 1/2 inch end mill to the edge of the part and called that 0. But that's not 0, that's a 1/2 inch beyond the edge of the part, so what we want, no, a 1/4 inch. So where do we want to go? Now we look to make sure we're not going to run into anything. Our Z is about, so now we can go to, if we go to 0.25 and 0.25, now the center of the tool is right over the corner. Because we touch the edge of the, because the tool is a 1/4 inch radius, 1/2 inch diameter. So now this is our real, now we want a 0x and 0y. And this will be, no matter what tool we use, this, the center of the tool will always be right here. So, to make your life easy, when you turn off the machine, before you turn off the machine, go to 0, 0. Turn off the machine there. So when you turn it on the next day, you'll know where 0, 0 is. You don't have to find the edge of the tool.
How did you know you were 0.25 in?
Because we moved it so the edge of the tool was at the
equal,
edge,
okay.
and it's a 1/2 inch diameter tool.
Got it.
So now we need to figure out where Z is. Fortunately, this machine, Z is something that you have to change a lot. So this machine has a magic option. Not magic, but a controlled option. So what we have is a metal plate like this, with a wire sticking out of it. If you have a metal tool, then it, basically what it does is it lowers, put this on the top of the surface. And what it does is it lowers the tool until it makes a circuit continuity and then says, oh, I must be there. And it knows the thickness of the plate, so now you can go to Tool, touch off Z0 position, and it goes down. As soon as it touches, now it knows exactly where the top of the part is. Because you're constantly changing tools, it's a really quick option to just change the height. So you only have to set the X and Y0 once. The Z0 you have to do with every single tool. All right, so now our tool knows where 0, 0 is.
Does that option automatically set the Z?
So it sets the Z to the top of the, or to the bottom of that, whatever that metal piece was. And no, because the piece came with the machine, so it's, well, it's an extra option, so you have to pay more for that, but it definitely saves you a lot of time, rather than going down and slipping with a piece of paper every time. All right, so this is shut. So we basically can run our first part. So basically we've put in our first tool. So now we pre-processed our program. We've looked at it to make sure it was the right program. You can hit start, load tool 1. Well, we already did that. So you press resume. First thing it's doing is it's basic. This is set up, even though you can't get the emergency stop, if you click anywhere on the screen, it stops it as well. So just click it anywhere, it will stop it. And then you can hit resume. I'm hoping my 10 inches is right. I don't want to cut into my vise. Yeah, okay, so it's fine. Anyways, let's speed it up. So there's a feed rate override. We said it was 20 inches per minute. Now it's 161% of 20, which is like 32. Now it's going to go a little bit quicker. So if doing a lot of facing operations, if you have a big tool, it's going to go a lot quicker because you don't have to do as many zigzags. Tells you when you're going to need the next tool to prolong operations. You're going to put the coffee in and come back. Didn't take too much longer. I think that was the time if it's doing at the normal feed rate, but we're doing it at 160%, so it's not going to take quite as long. That'd be right. I don't know.
I don't think our block was flat.
Cutting that last bit of air just to make sure that that's alright, while we're waiting. Oh, launch roll tool, good.
Why does it flash so fast?
It's hyper. So things to consider. Do we really need that side of the corner on our fish?
No.
No, we don't. But we chose to do that because we thought it would look cool. All right, righty, tighty, lefty, loosey. Which way would it go?
There you go. Right.
Are we going that way?
Yeah.
No.
That's the other way?
I think so.
No, that's how you tightened it. You need to go the other way.
This is how I loosen it?
Yeah.
We need some showing?
First time ever don't I want this
No, it's not like you would come anyway.
Yeah, actually, well, the brass has to re-record some parts.
Today was
Sure. The brass recorded and it talked about how perfect and great it was. And then the vocalist had redefined it. And then he's like, you know what, the brass has some flaws. We're going to do it. Well, you got to give him credit. Thanks. Why did you guys bring
You have to calibrate this here.
You always have, every time you have to calibrate the Z. Let's just speed over there. show Z0 position. You sure you take this out of there before you start machining? Otherwise, all right, we've loaded tool 2. Now we can hit resume. It goes back to where it stopped. Remember how it's going to plunge down in a circle? Crank it up. going past the edge because we basically do a rectangle bigger than the edge, so we don't have to, we'd have nice square corners. If you're doing this for mass production, then you would basically go back and edit your program so you're not doing those last few passes, because then time is of an essence. Or if you're doing one-off, then it takes longer to do that than it would do. Cutting the outside real nicely in the air. And it always goes up. I don't know why.
All the way?
All the way. And it goes back down. And it goes back down to where we started the program. That was where we were when we zeroed it. So now we should be able to open it up. Our fish even has a curly tail on it.
I like the curly tail.
That's character.
Oh, that's weird. That got messed up.
So that's what you get when you do wood.